I would like to provide a sample configuration that shows how to set up basic wireless LAN connection with the use of Juniper WLC series controller, and just a few words about HP WLAN 850 controller. So both of these devices are end-of-life devices, not Juniper or HP produce them anymore. So a couple of days ago, a friend of mine asked me to help him to configure Juniper WLC in his office. And you know what? I've read a couple of Juniper configuration guides and just couldn't find any sample scenario about how to connect the controller to an existing network infrastructure. They somehow trying to explain complicated things in a large environment, but nothing that makes you understand common things. So here I'm gonna show how I set up and running that thing. So first, let's see the topology. Here we have a standard set, just a router SRX 240, which performs NAT and DHCP functions, core switch, WLC controller, and gauge or access switch. So in the core switch we have data VLAN for the internet traffic, management Wi-Fi VLAN for an access points, and maybe MGMT all VLAN for management for all devices. So WLC controller is connected to the core switch with aggregated trunk interfaces just for redundancy, and access switch is also connected to the core with a trunk interface. Okay, let's have a look at network configuration on the controller. This is the most interesting part for me, actually. So first of all, we create two group interfaces, just port 1 and port 2, which is directly connected to our core switch. Now we're ready to configure our VLANs, because our VLAN, you see this 532 named management Wi-Fi VLAN, and we map it to our previously configured port EX2200 with a tag 532. This VLAN is necessary for access points connection. So I have VLAN 1500 named MGMT all with the tag 1500, and we also map it to the port EX2200. Then I just created 302 data VLAN. That is our internet VLAN, and the same logic, VLAN is mapped to port EX2200 with a tag 302. Okay, and okay, here we assign the IP address of the 532 VLAN, and take a notice at the IP address. This is the address of the controller DHCP server, which provides a pool of addresses for access points, but not for clients. You can see that DHCP pool is enabled to lease IP addresses with that range. So we should assign addresses for the rest of our VLANs, 1500, and for our data VLAN 302. The IP address of VLAN 302 is the address from DHCP pool. This is SRX DHCP subnet, which provides the internet access for our clients. And as you see, we have two DHCP services, one for client internet access, and another one is the controller DHCP for access points. So Wi-Fi clients receive SRX DHCP pool addresses, whereas access points receive controllers DHCP addresses. That's why we need management VLAN. So access points they should get the IP addresses from a controller DHCP server. And so at the end we have two trunk ports, which is connected to our core switch here. Okay. All right. Now let's consider configuring service profiles. And excuse me, it's not this one. So now we need to configure local switching. WLA's access points can be configured to perform local packet switching. Local packet switching allows packets to switch directly from the access points to the wired network instead of passing through the intermediate WLC controller. When WLA access points is configured to perform local switching, the WLC controller is removed from the forwarding path for client data traffic. When local switching is enabled, the client VLAN is directly accessible through the wired interface on the WLA. Packets can be switched directly to and from this interface. Normally, when local switching is disabled on a WLA, packets are tunneled through the network back to an WLC controller and traffic is placed on the client VLAN. This process requires packet to be encapsulated and maybe possibly fragmented, which may introduce latency in the switching path. So removing the WLC from the forwarding path for client traffic eliminates the tunnel encapsulation process, which can result in improved network performance. So local packet switching is disabled by default, and WLA can be configured to switch packets for some VLANs locally and tunnel packets for other VLANs through the WLC switch. Okay, now we're gonna switch maybe two VLANs. One VLAN, data VLAN for the internet traffic, and another VLAN is the management Wi-Fi. So to enable local switching on a WLA, VLAN profile should be configured and applied to WLA access points. So the VLAN is initiated when clients are connected and are authorized on the VLAN. So here we should enter a separate set VLAN profile comment for each VLAN you want to add to the VLAN profile. VLAN profile can contain up to 128 entries. When the optional tag value is set, it is used as the 802.1Q for the VLAN. And of course, we need to enable local switching on a WLA access point, which are connected to the controller through the intermediate layer 2 network. Okay, you see, I just created a VLAN profile named local switching data with VLAN tag 302, and I just applied to access point number 10. This is just a number. You can indicate whatever you like, whatever. And also the same way for access point 20. I just also enabled local switching for this access point and so on. And okay, let's move forward. Now we need to configure service profiles. And service profile is a set of options configured and deployed on the wireless network. Service profiles are configured to provide various types of wireless options to users, such as secure access, voice over IP, guest access, open access. Service profiles control advertisement beaconing and encryption for SSID, as well as the default authorization attributes to apply to users accessing the SSID. Other attributes include authentication type, authentication location, user group, VLAN, and encryption type. Here we have service profile called residence pub with a SSID called internet. As you see, so we have no authentication here. Now you see that SSID type is clear. So I've just configured all these parameters. It's some kind of a standard set of the configuration, and I've just activated the BGM standard here, wireless standard here. And the last comment here maps our service profile to VLAN data, which is required to provide the internet access for clients. Now we are ready to configure radio profile. So radio profiles are also used to control traffic parameters on the WLA radios. These radios profiles map to service profiles as well. So radio profiles are used to control beacon intervals, how often a radio advertises SSID on the network, and other parameters that you want to apply across all radios on the network. If you want to control individual radios on WLAs, you have to configure the parameters on each radio separately. So here I've configured radio profile residence RP1, and you see this is and the last okay, and here we should enable this radio profile. I just negated some features here, and the last comment is used to map radio profile to the service profile. And the last step is to configure WLA connection. So I disabled here AP auto mode and have to manually configure each access point. As you can see here, I indicated AP number 10. Then AP serial number and model. Then for AP10, I've just configured radio 1. This is for 2.4 megahertz, and map this AP to the previous configured radio profile residence RP1. So then I disabled radio 2 for 5 megahertz. We can configure the rest access points exact in the same manner. All access points should be connected to the ports assigned to management Wi-Fi VLAN on the access switch, and the PCs, users' PCs must be connected to VLAN data 300.02. Okay, let's talk about switch configuration maybe. So I have configured trunk interface group, just one group for access points. As you see, it has a port mode trunk and contains data VLAN and Wi-Fi management VLAN, so indicated as a native VLAN. So why should we need a native VLAN? That's an interesting question, and the answer is access points should require their IP addresses from the DHCP server through the untagged VLAN, and that's why we need this native VLAN ID, because native VLAN ID goes through the trunk without tagging. And I have another interface group. This is in the port mode access, contains VLAN data. So then I've configured interfaces. You see, we have some kind of a range of the interfaces on the switch, and we should apply to that range previously configured interface group. for that. Okay, then I've just configured aggregated ports, aggregated interfaces here, with also in the port mode trunk. That's between the switches, and it contains data management Wi-Fi. And the last step is to configuring VLANs. I have 3 VLANs, but you can add whatever you like. So that's the main configuration. I would like to demonstrate a simple configuration, just an existing network infrastructure, and we need to connect our WLC controller to this. We don't have any trunk ports or native VLANs here, so we have only one DHCP server, which is configured on SRX 2040 for clients and also for access points. So I've just installed virtual WLC controller on my VMware on MacBook Pro. So let's configure it. And the first thing we should do is type enable mode, and we should enter password, no password for this. And the first command we issue is the quick start. Okay, we agree to this. Yes. And it will ask us some questions like system name, country code, system IP address. Excuse me. Okay, net mask 0, default route. No, we don't need any tagged ports. WebView yes, and username admin, just the password here. Also we should type enable password. Time nope, and wireless no. Okay, let's see the default configuration. And the first thing we should do is to remove port 1 from the VLAN 1. So we just type clear VLAN 1 port 1, yes. And now we should assign our ports. So I will create a port group for redundancy, just in case maybe. Actually, it's good practice to configure port grouping. Set port group. We should indicate a name here to EX2200 core, and we should map it to our port. This is port excuse me, port 1 and mode on. Now we should set up our VLAN 302 name data. We should map it to our configured port. Port to EX2200 core without any tag. Then we should enable DHCP server on that VLAN. So we type interface of VLAN 302 and type IP DHCP client enable. Okay, now we should enable local switching, and for that purpose we need to configure our VLAN profile. So set VLAN profile local switching data VLAN data. Okay, now we need to activate local switching on our access point, so we need to define our access point. It will be set AP10. This is just a sequence number of my access point, the first access point. You can choose any number you like. Serial ID MG 021 20 58 3 6 8 model. I hope it's correct. I should check it again. MG 02120 58368 model WLA. You can see all models supported here, and our model is WLA 532-WW. Okay, now we should apply local switching and to our access point. Set AP10 local switching mode enable, VLAN profile, local switching data. Okay, so now we should configure our service profile. It should be set service profile residence pop SSID name internet and SSID type clear without any authentication. Then we should indicate authentication fall through last resort. And now we're going to configure our BGN mode manually. Of course, you can do it by default, but I would like to show you how to do it manually. So set service profile residence pub, transmit rates 11B mandatory 5.5 11.0 beacon rate 5.5 multicast auto. So now we can do it for (11G) transmit rate 11G mandatory. You see all these values defines here. 5.5 6.0 and now the last one is the 11NG. Transmit rates 11NG mandatory. You see all these values defined here, so mandatory. Now can rate 11.0. Multicast rate auto. Okay, now we should map our service profile to our VLAN data. So let's type set service profile residence pub VLAN name data without any tag here. And the last step is to configure our radio profile and map it to our access points. But you know, our radio profile should be mapped to the service profile also. So let's configure the radio profile. Set radio profile residence RP1 RP1 should be power policy max coverage. This is by default, and then we should map it to our service profile residence pub. Okay. Now we must map it to our access points. Set EP10 radio 1 radio profile residence pub RP1 mode enable, and set EP10 radio 2 mode disable. Okay, I don't want to use 5 megahertz for my wireless. So I suppose that's all. So we should check our configuration here. I believe it's correct. Anyway, now I'm gonna connect my access point to the switch. So our access point should receive IP address from SRX DHCP server on VLAN 300.02, and now it's booting up. We should wait maybe a minute or two. Now I'm going to show you how to check the interfaces and ports. You should type show port status, and you see our port number 1 is up. It's 10 gigabit adapter. Then show interface. You see our interface data for 300.02 data VLAN is down. So our access point booted up. And now we can check the interface here. So I have IP address for VLAN data from my DHCP server and show port status. It's up. So now let's check the Wi-Fi connectivity here. So as you see, I have the internet SSID. I'm trying to connect to that. Okay, here we go. And I can ping the Google DNS server, whatever. So I have internet on. It's working good. Okay, now I'm gonna change configuration a little bit. So I want to configure MGMT Wi-Fi VLAN, so the access points should receive their IP address from the controller, the HTTP server. But for this, we should configure trunk ports on the switch, which include data VLAN 302 and MGMT Wi-Fi VLAN 532 as a native VLAN. So the controller and access point should receive should be connected to the trunk ports, and Wi-Fi users will receive IP addresses from the SRX DHCP server. So we need again create our VLANs, data VLAN, and set VLAN 302 name data. We should map it to our port. Port to EX2200 core with tag 302. We should set the IP address for that. Set interface 302 IP address from our SRX DHCP pool subnet 1, 2, and subnet mask 24-bit. Okay. Set VLAN 532 name MGMT Wi-Fi. Okay. And we should also map it to our port with a tag. Port to EX2200 core tag 532 and IP address for that VLAN. Set interface interface 532 IP will be like that. Also 24-bit mask, and we should enable the DHCP server, internal controller DHCP server, and set interface 532 IP DHCP server enable. So let's have a look at the configuration here. Okay. Okay, now we need to change VLAN profile string. Set VLAN profile local switch data VLAN data tag 302. Okay, let's save the configuration here. I hope it's correct, maybe. So just let's wait our access point to boot up. And now a few words about HP850 wireless controller. So I have here a sample topology again. So we have only one access VLAN 24, no trunk ports or native VLANs. We have just one internet VLAN 24. So just a few words about configuration here. So here we're configuring and managing ports. So first of all, I create VLAN 24, you see, and here I assign IP address for that VLAN. Then I choose our gigabit Ethernet port and assign this port to VLAN 24. Then we should create virtual interface. It's called WLAN ESS2. So WLAN ESS interface, virtual layer 2 interface. It operates like layer 2 Ethernet ports of the access link type. Also support multiple layer 2 protocols. So, and then I assign this virtual WLAN ESS2 interface to a previously configured VLAN 24. Then I should configure service template. As you see, I have service template clear with SSID suite. I have no authentication here, so I have authentication method open system. Then I just map my virtual interface WLAN ESS2 to this service template and enable it. Okay, The next step is to configure radio policy and access point templates. Here I have the string auto IP enable. It means that access points should register automatically without identifying the serial number of the access point. So I should indicate only a model. As you see, serial ID auto. Then enable radio 1, radio policy radio 1. This is the default policy for 2.4 megahertz, and then I enable service template here. And enable radio. Then we configure radio 2 for 5 megahertz. Then I map it to the service template 2. Again, this is a default template. The correct way is to configure access point groups. Here I have default access point group, and for each access point you should configure the template separately. That will be the right way to do, but this is just a sample config how to route this controller, that's all. And the last command is to enable radio 2. That's all. I hope this video was informative for you, and I'd like to say thank you for viewing.